Hello and welcome to this Effervescent tutorial. Today I'm going to show you how to drop a tablet into the water and then spawn bubbles from it. Once we are happy with the motion, we're gonna see how to render it with Redshift using instances so that it just uses low memory and processing time. Remember, you can get this file from the link I've left on the description. So if you are only interested in the finished setup, you can skip this tutorial and just get the file. So let's start by animating the tablet. What we want to do is to make the particle go down and then stop at the bottom. We could animate it by hand, but I'm going to show you how to do it entirely with Tyflow. So let's create a Tyflow object. Here it is. Let's open the editor. Okay. Now the way to import this object into Tyflow is by using birth objects operator. We select pick the object, and now you can see that both are here, the original object and the Tyflow object. So we're gonna hide the original object. We don't really need it anymore. Now we have this. If we play it, nothing's happening. But now if you want to create a simple physics objects, Tyflow has physx. The physx shapes operator is doing a few things under the hood. As you can see, as soon as you apply it, the object will fall down, affected by gravity. So what physx operator is doing is creating a default gravity and also creating a ground collider. That's cool, but the problem is we need to simulate the tablet going underwater. So it needs to slow down. How can we do that? Well, one way to do that is go into the Tyflow properties, physics, and here you can see the default gravity. We can lower it to something like this, and then play, and you can see that now it's going slower, but it's a bit boring. We would like to spice it up by using, for example, a spin operator. And we want the spin operator not only to be active at the beginning, at the first frame, but continuously. So now we have this rotating. It never stops because it's in continuous mode. So we would like it to stop when the tablet is close to the ground. And the way to do this is we want this spin operator to be deactivated when the tablet is close to the ground. So we're gonna go to the filters part of this operator and we're gonna enable it. Filters are like conditions in Tyflow. So we're gonna add a condition here. And by default it's based on the position X. We don't really want this. We want it based on height, which is Z. The problem is, what's this number? So at what height should it stop working? We don't really know because there's no indication here. So Tyflow has an operator called display data. And display data is going to show a lot of values, whatever you want actually, a lot of things. By default it's showing the ID, which is 0 because it's the first number. We don't really want this. We want the position. And as you can see here, you can see the position in X, Y, and Z. And we would like the tablet to stop spinning around, for example, 5 or 4. So let's go to spin, and here let's change this value to 3. And now it's doing this condition. Keep spinning when the position is less than 3. We don't really want this. We want the position to be greater than 3. So it will spin until it reaches 3 and then stop. Let's see if it's working. Okay. Yes, it's working. I'm gonna change the spin a bit so that it doesn't get stuck like this. We want it to fall. Let's change it to something like this. Yeah, maybe a bit less. Okay, but I think it's going too fast, even with the reduced gravity. So what I'm going to do is I'm going to use a slow operator, which is some kind of friction inside Tyflow. And the slow operator lets you affect the velocity and the spin. For the velocity, we're going to use high number, like 90%. So it goes like in a slow motion. And we're gonna reduce, we're gonna affect the spin by 40%. Let's see what happens. Okay. I'm gonna make it stop spinning a bit earlier. So this is gonna be affecting from, for example, 10. Let's see if it works. But it is, you can see it's working, but it's too abrupt, too harsh. So I'm gonna reduce the friction here to something like 15. Let's see what happens. Still too much. Let's say something like this. That's better. Let's play it in real time. I'm gonna reduce the spin. Now it's 150. I should use it to 100, for example. That's not bad. Of course, it's entirely up to you, depending on what you have in mind for this, but it's gonna work for us. So let's move on to the next thing, and we're gonna create a lot of bubbles being spawned by the tablet while it's falling down. So let's rename this original Tyflow. I'm gonna call it Tyflow _ tablet. Open editor, and then we can press this new, and it's gonna create a new Tyflow object for us. This Tyflow is gonna be Tyflow _ bubbles. And what we want to do is to make a lot of bubbles being emitted and going up, and maybe going down once they reach the upper part. So how we do that? We need to tell Tyflow to emit from an object. So I want to create a birth operator, from 0 to 300. I'm going to increase the number of particles. And now we're going to use a position object, operator. This is going to allow us to emit from this. So let's go here and I'm going to try and pick this tablet. As you can see, I cannot do this. Why? Because the position object is expecting a mesh. And this is not a mesh, this is a particle. So what can we do to change this? Well, we're going to go to the original setup, Tyflow tablet. And I'm going to use a mesh operator. This is going to turn this into an actual mesh. Let's see if it's working. Go to Tyflow bubbles and try and pick it now. We still can't pick it. Why? Because even if it has a mesh, it's still a particle system. So the only way to do this is we go to the mesh operator. You can see that it's a triangle mesh, but it's set to render only. We disable this, and now you can see that the color has changed. So that's indicating that something is different now. Let's try now. Let's go to position object, pick. Now it's working. And immediately you can see there's something happening here, which is very cool. Now what is happening is that it's spawning particles from 0 to 300. So if you keep calculating, you'll see that it would not stop. It's not what we want. That's not the behavior we want. So what we want to do here is to create some kind of swirly motion. Let's see how we can do that. So first of all, what I want to do is create a slow operator, the friction, if you remember. It's always a good practice to add this, because otherwise particles can get out of control very quickly, especially if there are a lot of forces and turbulences happening at the same time. So I tend to do that always. So next thing is we want the particles to go up. The way to do this is using a force operator. And here you can see that's a built-in gravity. You might be wondering, is not Tyflow adding a default gravity? Actually, it's not. Tyflow is only adding a gravity if you are using physx. Now we are not using physx, and we don't plan to, because there are a lot of particles here and we don't really need accurate collision between them. So let's do something like 0.2. You can see that it's way too fast. Let's go way lower. Something like this. Yeah, that's more like it. That's cool. Now the motion is too regular. We're gonna use some kind of turbulence here. In the same force operator, you can see there are a lot of options. Apart from gravity, you can use noises, and you can stack layer noises one on top of the other. So let's start by this noise layer 1, and we're going to use a call turbulence with a value, or this, well, I use the same value of here. It's a good indication. Something like this. I'm going to increase the frequency. And you can see that it's doing some kind of swirl, and then maybe we can increase the scale so that it's not as visible. Yeah, something like this. And now we can add the second layer of turbulence. I'm going to use a call here with a value of maybe half of it, half of this, something like this. The frequency, I don't know, it could be a quarter of this. And for the scale, we want it to be very small scale, something like triple that. And let's see how it looks. It's not bad. What we would like to do here is make it go up, and then they reach a certain height, and then they go down and maybe swirl around, something like this. So how can we do this? We're gonna use a operator that lets us set a condition, like some kind of property. Here it's called property test. And the property test is gonna check for a height, and then when this is greater than some height, it will send all the particles to the next event, and something different will happen in the next event. Now it's a good time to rename this and call it emitting bubbles. Okay. Now it's happening the same as before. How do we know the position of this? Well, we are going to use display data. We disable birthday ID and activate position. And there's a lot of information here, but let's just focus on one of them. So let's say we want the particles to go down, like when it's reaching 30. Let's disable this for now. And here we can enter this number. Positions in Z30. So now what's going on? Nothing, because there's nothing. They are not being sent to another event. Well, if you drag this, you can create a new event. And the display for the first event is red, and for the second event is green. So you have a visual indication of where the particles are reaching the height. Now, what we want to do with this? Well, for starters, I'm going to use a force. I want to use a gravity here. And I'm going to use minus 0.1. So now, when they reach, they go down. Of course, we're going to use a slow operator as well here. Let's add it. A pretty high one, like 70%. Don't forget we are underwater, so we want it to be very slow. Okay, so now they are not moving in a natural way, but we're going to fix that. We're going to add another force. And I want to keep them separated, because sometimes you want this to only affect the particles for a few frames, and then this is going to be a turbulence, and maybe the timing is going to be different. So it's a good idea to keep them separated in this case. And for this, I'm going to use a combination of curl noises. Let's add curl 0.2, frequency, for example, something like this. These are values that I know that work properly, but feel free to experiment with them. And then I'm going to use another call here. And let's see what it does. Okay, that's good. So let's say that we want the water to end here. So the particles shouldn't go higher than that. So let's tell Tyflow to stop doing that. Now, to do this, I'm gonna move to the top and use a plane. This plane is going to be the collider. Something like this. We're going to rename this to collider. And we're going to use a collision operator. And then we pick the collider. Let's see if it works. Yes. That's good. Of course, if you want to create like some kind of narrow glass, you could duplicate this this plane and use it on the sides, or create a cylinder with a shell operator, for example. I'm going to show you really quick how to do this. Cylinder, something like this. Yes, something like this. And then I'm gonna reduce the height, and then I'm gonna use a shell operator only for the inner part. This is to make sure that the inner part of the cylinder has proper normals. And then I'm gonna pick it in the collision. Let's see if it's working. I think it's working. The problem is we need to add this collision also to the first event so that the red particles don't go through it. Let's see if it's working. Okay, now it's working. That's only if you need to simulate some kind of glass. Otherwise, feel free to ignore this. Okay. Also, it's a good practice to select these. I'm gonna call this glass collider, and uncheck renderable, because otherwise you're gonna forget about them, and then when it's time to render, it's gonna appear. So let's hide them, and now. Okay, so I think it's working. Sometimes you can see that there's something weird happening here with the particles. It's like it's appearing in places that it shouldn't appear. So sometimes you need to go to the Tyflow object and under settings, change the time step to something like 1.2 or 1.4. So it's going to be more accurate. I think it's time to add some actual bubbles here. Right now there are only dots, and it's good because it's updating very quickly. But now we would like to see the actual spheres here. So I'm gonna add a shape operator. By default it's using a triangle. We're gonna change this to 3D and geosphere low res. Now it's updated and nothing is happening. Why? Because by default Tyflow is showing small dots. We're gonna change this to geometry, and now it's working. Don't forget to change this as well on the second event. Geometry. Let's see. So right now they are too big. Let's go and change this. Here on the shape scale, we can use something like maybe 10%. and with a variation of 8%. But I would like to have some bigger bubbles as well. So the way to do this is you select this one, this low-res geosphere shape, duplicate it, and now I'm gonna increase this. I don't want to have the same amount of big bubbles and small bubbles, so what I'm gonna do in the big bubbles, I'm gonna change the frequency to something like 5%, maybe 2%. I'm gonna use a 5% and maybe something like this. It's something entirely up to you. If you feel you need more big bubbles, whatever you need. And I'm gonna increase the number of them. It's something I do at the end of the setup because it's gonna slow it considerably. Okay, so now it's working. I think it's time to render this. For this, I'm gonna use Redshift. So I'm gonna change this to Redshift render. I have half HD here. And I'm gonna leave everything on default. So let's press this IPR, which is interactive render. Let's see what's going on here. We can see there's nothing happening because Redshift doesn't really understand Tyflow by default. We need to do a few things before it works. The first one is I'm gonna use a mesh operator that it's gonna turn these particles into something that Redshift can understand. And instead of having triangle meshes, I want it to be instances. This way, Redshift will understand that it's the same particle copied again and again, and the memory consumption and the processing time is going to be low because it's just processing one and copying it. Okay, so let's refresh here, and we have something working here. Don't forget to add this mesh operator to the second event as well. You need to add this to all the events you need to render. And now you can see that everything is coming here. There's something else we need to check. If you select the Tyflow bubbles object, you need to come to the interfaces and make sure that enable particle interface is checked. Otherwise, if it's not checked, nothing will be rendered. So make sure it's checked. Okay, now it's time to create a material. I'm gonna rename this material to bubbles. I assign it. Let's reload, okay. And then I'm gonna change it to Redshift material. And I'm gonna change this from the preset to water. On water, I'm gonna reduce the dispersion. I'm gonna set it to 0 because dispersion is creating some kind of multicolor effect that I don't really want. Okay, something is happening here. Good. Let's close it. For now, we can close Tyflow as well. And as you can see, particles are not visible anymore. That's because they are using the transparent setting of the material. For now, I'm gonna change it to clay. So clay it's ignoring this material transparency setting. Well, first of all, I'm gonna create a camera. Go to perspective, press Ctrl C. Now we have a physical camera created for us. I'm gonna get it closer and back away. Something like this. Let's go to top view. I'm gonna create a physical light, which is gonna be an overhead light. A light that's gonna be over the particles. That's good. Let's check the intensity. By default, I think it's 100. 5 is much better. And now I'm gonna copy this. And I'm gonna position this light as a backlight, because I want most of the light to come from above and from the back. Make sure that these lights have a low intensity, otherwise it's going to be blown out. Although I'm gonna show you that Redshift is actually set to use ACES. So ACES is gonna preserve your highlights much better than the regular options here. So let's change to the camera. It's getting closer to what we want. So let's reduce this intensity. Just a note here, by default I think the Redshift lights are visible with this check. If this happens to you with a very bright white background, it's because the lights are visible. Just uncheck it. I'm gonna reduce this to, I'm gonna rename this to top light. This one to bright light. This one to left light. This way it's going to be easier to adjust. Okay, I think it's looking good. I'm going to do a final thing here. I'm going to switch to advanced mode of Redshift. And here we have a tab called motion blur. So I'm going to enable this motion blur. And I'm going to reduce the duration of motion blur to half of it. Maybe increase the steps. These steps are going to show a more accurate motion blur. And as you can see, it's working right away, because all these steps we have followed to make Redshift understand the information coming from Tyflow is helping Redshift to do correct motion blur. If we check other frames and press reload here to update, you can see that everything is working. Also, you can see that the interaction you get from it is very good, because although we have a lot of particles, they are just instances. That's all for now. Hope it helps. Remember, you can get the final result of this tutorial and even a few more things in the link I've left on the description. You can get this finished setup with an additional system of disturbance, in which the peel is going to be moved by the bubbles as they go up, and in general a more polished result. Check it out and see if you find it interesting. Thank you.